All right, so now in this case, let's look at, arrange the following in increasing melting point. Increasing melting point, we are looking at higher intermolecular forces. All right, so let's look at all these three molecules we have. Chlorine, which is really nothing, no intermolecular forces, diatomic gas, and not even that much of a higher molecular weight. MgCl2, which is ionic compound. So if this is ionic, I have electrostatic forces. For CCl4, which is this, we've drawn this before, tetrahedral, I have only van der Waals forces, van der Waals or dispersion forces. Okay, so to look for something that is increasing in melting point, it means that I have to look for higher intermolecular forces. So MgCl2 is higher. Then CCl4 is next because it has dispersion forces, higher dispersion forces than Cl2. Okay, Cl2 is only a diatomic molecule, whereas CCl4 is polyatomic. So that's your order for increasing melting point. Okay, ionic highest. Again, in the next one, then we have sodium hydroxide. Again, this is electrostatic force because sodium hydroxide is a metal and a non-metal bonded. So it's ionic compound, electrostatic force. CH3OH. Now I have hydrogen bonding because of the OH here. And then C6H5OH. So again, also I have here hydrogen bonding, but I also have C6H5 compared to CH3. So this one will give me some dispersion forces also. So now if I have to compare this, I will go with sodium hydroxide first because that is ionic. Then I'll go for C6H5OH because that's got two types of forces, dispersion forces and hydrogen bonding. And then the last will be CH3OH because that has only hydrogen bonding. So that's my order for increasing melting point. Now let's look at another typical question that I will ask you, which is about solubility. Okay, so below are three solvents A, B, and C. Indicate which substance will dissolve in which solvent and what is the ion force, the intermolecular force involved. Okay, so which means you're looking at the interactions between the solvent molecules and the compound molecules. Okay, so the solvents that I'm given are A, which is water, B, which is the CH3, CH2, CH2, whatever, CH3 all the way, and then C, which is CH3, CH2O, CH2, CH3. This is an ether, okay, by the way, and this is hexane, the B. Okay, so we have water, hexane, and ether. Okay, so let's look at the compounds we have. So we have sodium chloride. So the first thing I'm looking at, okay, so I have sodium chloride. Sodium chloride is a ionic compound. If it's ionic compound, then I need something very polar to dissolve it in. Okay, and so that would be water. Okay, so it's soluble in water, and the intermolecular forces involved would be then ion dipole forces because ions coming from the NaCl, dipole coming from the water. Those are the interactions between the solvent molecule and the solute molecule. The next one is CH3, CH2, 8, CH3. So I have 8 of the CH2s. Looking at the structure of this compound and B, solvent B, they resemble each other. So it should be, both of those should be soluble in each other. In hexane and in this compound here, the CH3, CH2, 8, CH3, the forces that are common are going to be dispersion forces because, yeah, there is no electronegative element and there is only carbon and hydrogen. There is no dipole forces at all, okay, involved here. So that's why it's just dispersion force. That is what causes these two compounds to dissolve in each other. Okay. Next one is CH3OH. So I'm looking at this compound, I'm looking at OH, which is hydrogen bonding. So if I have hydrogen bonding, my solvent should also have hydrogen bonding or some sort of dipole forces. So water is clearly the choice over here, and this is because of hydrogen bonding. I can also use ether, by the way, but ether will not be the best solvent. Okay, I should choose the best solvent. not any solvent. So water is the best solvent for this. Now for CHCl3, which is also chloroform. So in case of chloroform, now I have some issues because chloroform is this. So where I have hydrogen, Cl, 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 all right? So which means that I do have some sort of dipole moment. So if the molecule has dipole moment, I need a solvent that has a dipole moment. So, but the problem here is that the Cl, Cl, Cl has dipole moment, but not enough for it to dissolve in water. Water is highly hydrogen bonding, very, very polar molecule. So the best solvent for this one actually would be C. That would be my first choice for this because it has some dipole forces. And then I would also choose B, okay, for it. So you can choose two in this cases, or you can give me whichever one and both will be fine, okay, in this case. So C is because of dipole-dipole. There is some dipole moment here, and B, it's soluble because you have some sort of dispersion forces, okay, because the 3 chlorines in the CHCl3 is causing dispersion forces, and then of course our solvent here for hexane is all dispersion forces. So because of that, you can have 2 solvents here. The last compound I have here is C6h5 Cooh, and we had this compound before also. And if you remember, we talked about that this is going to give us hydrogen bonding, and the extra oxygen here causes for a little bit of dipole-dipole interaction. So if that's what we have, then to dissolve the hydrogen bonding component of this one, A would work. Okay, so you can have water, it will dissolve in water, and then it can also dissolve in something that has some sort of dipole-dipole forces, which would be C, which is the ether again. Okay, and so A would dissolve because of H bonding, and then C, it will dissolve because it has dipole forces, but not only because it has dipole forces because of the oxygen, but see the C6H5 here, that is non-polar, okay, because that causes dispersion forces. So you have dipole-dipole forces as well as dispersion forces. So if you had to choose a best solvent for this, I would go with C, not A, okay, because with C it has 2 types of intramolecular forces. So in this case, I will give you points for both A and C, but C is the better choice, okay, for this one. Then I know that you've completely understood intermolecular forces. Okay, I hope that helps.